Trigonometric inverses. The key to this lesson is going to be your ability to either use the unit circle or your special right triangles for your 45, 45, 90 and your 30, 60, 90. When you're using your unit circle, you need to remember that your cosine, and unfortunately my pen is not working today, so I got to do this a little harder. Cosine is always going to be your x value, and sine is always going to be your y value. So when you're looking at these, for instance here at pi over 2, the cosine of pi over 2 is 0 and the sine is 1. On your 30, 60, 90 triangles, really, instead of having x root 2, x 2x, x root 3, we can just have these all as ones. So it's root 3, 1, and a 2. And then same thing down here, we can just make it a 1, and a 1 root 2 to make life easier. So let's get started by first looking at our functions. When we're dealing with trigonometric functions, we have to limit the domain in order to actually get a function. Because if you were to graph arcsine or the inverse sine, you would get a graph that's not a function because it wouldn't pass the vertical line test. So what mathematicians do is they delineate the difference between when we want to use an entire function or when we want to limit the domain by using these capital letters. So capital S with sine and capital A with arcsine, that means that we want to look at values where the domain is between negative pi over 2 to pi over 2. That's one rotation before it starts repeating again. And then notice with arcsine, the domain becomes the range and range becomes the domain. That's because with inverse functions, the x and the y switch places. So when we're answering the problems today, we're going to want to make sure that we choose values that are only between negative pi over 2 to pi over 2 when we're dealing with sine and arcsine. With cosine and arccosine, we're going to want to be dealing with functions that are between 0 and pi on the unit circle. And then tangent, we're going to be looking again from negative pi over 2 to pi over 2. So if you need to, pause the video and write down those ranges that we're going to use for each one of the functions. So the first thing you have to be able to do in this lesson is you have to be able to write an inverse equation. And this goes back to Algebra 2. When you're writing inverse equations, the first step you have to do is you have to switch the x and the y values. Once you switch it, our goal then is to solve for y. And then since we're dealing with trig functions, just like multiplication undoes division, or adding undoes subtraction, if we have an arctan in the problem, to undo it, we use tan. Or if we have a tangent in the problem, to undo it, we use arctan. So in this problem, our initial equation, let me make this bigger, is y equals arctan 2x. So our first step is we want to switch the x and the y values. So that's going to become x equals arctan 2y. So all I've done is I've switched the values. Now, we can pretend that this 2y is basically in parentheses, so it's stuck with the arctan. So to get rid of it, we would need to multiply both sides by tangent, like that. And when we do that, our tangent and our arctan over here cancel out. So that leaves behind the 2y. So now that gives me tan, and we want to make sure I have not been following the rules for capitals, I'm sorry. Capital tan x equals 2y. And now our last step to get y by itself is we would divide both sides by 2. So that basically gives us 1/2 tan x equals y. And that would be your answer. So the main thing you have to remember from Algebra 2 is you have to switch your x's and your y's and then solve. And the one thing you are going to have to be careful about is what they give you in parentheses or connected to your function. Is it connected to it or is it outside of it, like with a plus sign, and needs to be moved first? So that's one thing to pay attention to. So let's go ahead and look at the next set of problems. These ones are the ones that can be kind of difficult because you have to think about, am I using the unit circle on the outside or am I using the actual values on the inside? So what this needs to connect back to is back to when you learned trig in the beginning. And if you wanted to know, you had two things. You could find sine of some degree, and that would give you a number. That was your side length. Or you would have a function that was sine x equals, and then there was some number on the outside. When I wanted to know this answer, and I'm going to have to switch over to my math calculator here, my math type. In order to find this answer, we had to type in our calculator, our inverse sine of 2.2. And that would give us our answer of what that angle was. So when I have my inverse sine or arc sine with the number, that means we're looking for the missing angle measurement. So when we have this, when it says arc sine negative root 2 over 2, basically what that's saying is for what value on the unit circle is the sine negative root 2 over 2. So first thing we have to remember is our domain. If we go back here to our domain and range, we have to be between negative pi over 2 and pi over 2. So that means we're basically looking over here at this quadrant. So if I look, I can see, and I'm looking for root 2 over 2 for now, I can see that my sine is root 2 over 2 when I have a value of pi over 4. So if I'm looking at this, I can see that my sine of negative root 2 over 2 happens at pi over 4. So we're going to say it happens at pi over 4. And then since this was a negative, we would also make it negative there. Now the reason why we couldn't go down here and say, well, here's negative root 2 over 2, why isn't the answer 7 pi over 4? And the reason is, remember, we had to restrict our domain from pi over 2 and negative pi over 2. And that value falls outside of that range. So we need to make sure we're always keeping within those ranges. So your answer here for arc sine is negative pi over 4. So if we were to go in reverse, if I were to say sine of negative pi over 4 equals, it would equal that answer. So now let's look at letter B. B is basically saying the same thing. It's saying for what value on the unit circle is sine equal to cosine of pi over 2. So we want to start on the inside, and first thing we want to do is we want to find what is the cosine of pi over 2. Well, if I go, here's pi over 2, and my cosine is 0. So first thing we're going to have is we can say arc sine of 0. So I took my answer from cosine of pi over 2, which was equal to 0, and I substituted it into my equation, simplifying it. And now it's saying, for what value on the unit circle is the sine equal to 0? And if we look, it is equal to 0 at 0. So our answer here is 0. So hopefully you're starting to see how we use the unit circle to solve these problems. We're going to do 2 more. So this next problem, letter C, notice now on the outside it's sine. So we're going to be looking for answers that simplify. And then we're actually going to be, once we simplify this to get a value, our final answer is going to be one of these numbers on the outside. Now the other tricky thing is that it's using tangent now. When you're using tangent, you may want to go back to your special triangles. Because tangent, we know in the triangles that tangent is equal to opposite over adjacent. And so it's a lot quicker to find your values on here than it is on here. So let's go ahead and look at this problem. And first thing it wants, for C, inside that parentheses, is it wants the arctan of 1. So the inverse tangent of 1, if I look at my triangle, the only way that I'm going to get a tangent of 1 by doing opposite over adjacent is a 45-degree angle. Because up here on 30, 60, 90, these are never the same. So that means arctan 1 is 45 degrees, and 45 degrees is pi over 4. So underneath here, we're going to put pi over 4. Now, we look at the second part. The second part wanted the arctan, arc sine, and again, we wanted it equal to 1. So if I look, I ask myself, well, when is sine equal to 1? And sine is equal to 1 up here at pi over 2. So now we can go ahead and simplify this. I'm going to change this to 2 pi over 4 so that we have common denominators. And when I subtract, I get negative pi over 4. So now my problem is the sine of negative pi over 4. And pi over 4 gives us an answer of root 2 over 2. So we have root 2 over 2. And since it was negative pi over 4, that means our final answer is negative root 2 over 2. So let's go ahead and look at this last problem, and then hopefully you'll be good to go on your own. So for D, we have cosine, but notice in the middle here, in the parentheses or in the brackets, they want us to find the arc cosine of negative root 2 over 2. So let's just bring this negative root 2 over 2 that I've already typed and bring it over here. And now we just look at our unit circle and say, when is it root 2 over 2 for cosine? And it looks like, again, it's pi over 4. So that means this whole chunk right here becomes pi over 4. So pi over 4. And now we bring down our minus pi over 2, which we've already solved. That was negative pi over 4. And so now if we look, they want the cosine of pi over 4 negative. And so pi over 4 negative is negative root 2 over 2 again. So hopefully this video has helped you break down the steps you need in order to solve the problems. I hope this helps.